Hello everybody, I'm Abhijit and I'm here to explain the first 5 projects out of the 30 projects which I am about to do after the completion of my first module of the Python programming. So let me begin without wasting my time. I'm here to explain the first 5 codings, first 5 problems. The first problem would be first problem is the scoreboard problem. And it shows the team London has played 8 matches and they have won 4 matches. For winning every match, they will be getting 3 points. These 3 points, and they have lost 3 matches and 2 1 matches. For losing the matches, they won't be getting any points. For drawing the match, that means for a tie, they will be getting 1 point. And the coding will be coding goes like this: defining the fixed values. W equal to 4 is they have won 4 matches. L equal to 3, they have lost 3 matches. D equal to 1, they have tied 1 match. So the total points, the calculation of the total points will be like this: TP equal to 3 into 4. That means 4 wins, each wins of 3 points. That is 3 into 4 plus 1 into 1. Uh, they have made a tie of 1 match, that is 1 into 1 plus 3 into 0. That means 3 into 0, they have lost 3 matches which has no points, that is 3 into 0. And after the calculation, we are printing the output, print of TP, total points, that is 13. We will get 13. Okay. The second one would be, imagine you are a nutrition bar. You have department head of your company produces a nutrition bar that contains 45 gram of raisins, 65 gram of almonds, and 30 gram of apricots. Head of the manufacturing department wants you to create an ingredient percentage list. So the ingredient percentage will be like the total grams. That means if you want to get the ingredient percentage of raisins, then the gram of raisins will be 45. 45 divided by the total grams, that is 45 plus 65 plus 30 into 100. Then we will be getting the percentage of ingredients of raisins. So this will be the formula, and the program goes like this. Right? Yeah, calculate the percentage of raisins and print the variable. So raisins is 45, almonds are 65, and apricots are 30. Calculating the percentage of almonds. Almonds is 65, right? So percentage of almonds is equal to 65 divided by the total amount, 45 plus 65 plus 30 into 100. Then we are printing the percentage of almonds and we will be getting 46.42. And similarly, we are printing the percentage of apricots. They are 30. 30 is the grams of apricots. 30 divided by the total, 45 plus 65 plus 30 into 100. Then we are printing the percentage of apricots. We will be getting the percentages 21.4. Okay. The next will be like, yeah. As we have created a machine learning model to detect diseases in patients based on their symptoms and medical history. The model has been tested on 100 patients. The total number of patients will be 100, including 30 diabetes, 45 heart disease, and 25 cancer patients. So these 100 patients will be divided into 30 heart patients, 30 diabetes patients, 45 heart patients, and 25 cancer patients. So the model performance was available in three rounds. The first round, the model correctly detected 25 diabetes out of 30 patients. That means they have totally 30 diabetes patients and they have diagnosed nearly 25 patients. In the second round, the model correctly detected heart disease 35 out of 45 patients. Total heart disease patients were 45, but it could only detect 35 patients. In the final round, the model correctly detected the cancer in 20 out of 25 patients. The total number of cancer patients were 25, but it could only detect 20 patients. So the question would be like, what was that? Yeah, the model's accuracy. The model's accuracy is defined as a percentage of correctly detected cases out of the total number. Access how accurate your model is across the 3 diseases. So our aim is to find the total accuracy of the model, including all the 3. So the heart patients is 45, diabetes patients is 30, cancer patients is 25. And the correct guess of the heart disease patients after round 1 is 35. The correct guess of the diabetes patients of the round 2 is 25. The correct guess of the cancer patients of the round 3 is 20. So printing the heart disease detection accuracy. So heart disease detection accuracy is like how many they have detected, that is 35, divided by total number of heart disease patients, that is 45 into 100. Then we are printing it. That means print, we are using the method heart disease accuracy date accuracy is. So this we are giving in this output, and we are printing the value which is stored in heart disease detection accuracy. For that we are given the variable like comma and the variable here. So we are printing it, we are getting 77.77. Similarly, the printing the diabetes detection accuracy. So diabetes detection accuracy is equal to 25. That is, the detected patients are 25, total patients are 30. We are multiplying it by 100. Okay. When we are printing diabetic detection accuracy is, this is the output we are providing. We are providing these characters, and the value we stored in diabetic detection accuracy, that variable we are giving after the comma here. So the output will be like diabetic detection accuracy is, so this we are giving, and the value which is stored in the diabetic detection accuracy will be printed here. So this is the value stored in the diabetic detection accuracy variable. Okay. Similarly, we are printing the cancer detection accuracy. So totally 20 cancer patients were detected out of 25. So we are dividing 20 by 25 into 100. Similarly, we are printing the data and we'll be getting the output. Okay. So printing the overall accuracy of your model. Our overall accuracy means the total patients were 100, and the accurate results were, let me show you, that is 25, 20, and it's 35, I guess. Let me check. Yeah, the correct guesses are 35, 25, 20. That is 35 plus 25 plus 20. That means I hope it's 80. 80, I think. At 25 plus 35 plus 20 divided by 100, that is total number of patients into 100. So this value will be stored in the overall accuracy, and we are printing the overall accuracy is, and this is, we are giving this characters, and this variable we will be giving here to get the value as 80 here. Okay. Next will be find the value of x equal to 3, x equal to minus 2, and x equal to 4. And the function f of x is equal to x square plus 3x minus 4. This is nothing, but we are function evaluated at 3. At the place of x here, f of x equal to f of x equal to x square plus 3x minus 4. This is the function. At the place of x, we are using 3. Where is that? X equal to 3, x equal to 2 minus 2, and x equal to 4. First we are evaluating x equal to 3. So function evaluated at 3 will be like, at the place of x we will be placing 3. So 3 square, that is 3 star star 2 plus 3 into 2 minus 4. And we are printing that, we will be getting the answer as 11. And the next one will be function evaluated at minus 2. So while giving for given the value function evaluated at minus 2, we will be like, we have to give minus 2 in a separate bracket. So this will be very necessary, I think. If you are not giving the separate bracket for minus 2, then we will be getting a different output, I hope so. Okay. We are giving minus 2 at the place of x, we are printing the value, and we will be getting minus 6 here. And then yeah, we are evaluating for x equal to 4. For x equal to 4, we are just replacing the x with 4, and this will be our equation, and this value will be stored here, and we are printing it here. We will be getting 24. Okay. Sorry. Yeah. Then check if function evaluated at 3 greater than or equal to function evaluated at minus 2. We'll have to just use this function evaluated at 3. For this, our output will be evaluated at 3. Where is it? Function evaluated at 3 is 11. 11 is greater than or equal to function evaluated at minus 2 is 6. So it is true, and we'll be getting the output as Boolean expression true. Okay. Similarly, we have to check if all the f of x at 3, minus 2 and 4 are equal to 0 or not. For that, we will have to just put equal to operator, comparison operator for every of the function evaluated at 3 equal to 0, function evaluated at minus 2 equal to 0, function evaluated at 4 equal to 0. So these will be checked, and will be and every all of the three will be like not equal to 0. It shows like we have got values minus 6, 24 and 11. So it's not equal to 0, and we'll be getting false. That's it. This will be the last one, I think. Yeah. Books. Question: the pursuit of expanding your knowledge of Python, you come across bookstore in search of books on your subject. You meet a salesperson who is also a Python developer. Salesperson is challenge. They have a list of 5 books related to Python, and if you can write a program that finds the count of letter E. Yeah. The store will give you a free book of your choice. Are you ready to accept the challenge? Accepting the challenge. The books are Python for Everyone, Learn Python the Hard Way, Python Crash Course, Starting Out with Python, Automate the Boring Stuff with Python. So store the count of books that containing capital E or small e in the title. Now this will be case sensitive, and finding the small e will be like, see, all the books name are stored in this variable name books. So the variable dot books dot, we have to count how many small case e are in the variable books. So books dot count of small e. So this can return how many small case e are in the variable books. And the next one will be e counts equal to capital E. Similarly, the variable name books dot count of capital E. This will count the capital E in the variable books. Okay. So now total e counts is equal to this small e plus this capital E. That means if this is 1 and this is 3, we will be getting 1 plus 3. Okay. So here we are counting both the uppercase and smaller case e's and storing in total e counts, and we are printing the value. The total number of the total number of e's in the list of book is e total e counts. That means this value. This is the variable. This variable will have the total number of capital E's and small e's stored. So the total number of e's in the list of book is 8. Okay. So I have explained the first 5 codings. So thank you. Thanks.